move to presentation number 3, we have Mohammed Roohan and Aqsa Akhtar from STS School, Aligarh Muslim University, and the session will be chaired by Alfaz and Atif Hassan. Aqsa is an 11th. Mohammed Roohan is a class 10th student of STS School, Minto Circle, Aligarh Muslim University, Aligarh. He secured 92.3% in class 9. He has good command in English, Urdu, Hindi. He loves playing badminton, poetry, literature, and debating. He's good in programming, application development. He has earned many prizes in state level, Bazi competition, district level Bazi competition. Presented international papers on topic reporting culture and awareness of adverse drug reactions as a component of the pharmacovigilance program of India. In the annual ASET Hybrid Conference 2024, former member of ASET Middle School Students Committee. He received International Student Leadership Award from ASET in 2024, winner of monthly ASET quiz, engaged in volunteering sessions like in Urdu, Kitab Mela, and open mic organized by Kuch Khas. Aqsa Akhtar is an 11th grade student at senior secondary school girls, Aligarh Muslim University, India. She is curious-minded and inspiring learner with a strong passion for the sciences, exploration, and continuous learning. Known for her critical thinking, effective problem solving, and organization skills, she has consistently maintained an excellent academic record throughout high school. Her interests span public speaking, content writing, sports, project work management, and leading initiatives. Aksa has Aksa has earned multiple ASET quiz awards and secured first prize in bioinformatics final quiz 2024. She is also a recipient of Best Girl Student Award and the Best All-Rounder Student Award from her school.
So, Assalamu alaikum everyone and greetings. I'm Mohammed Roohan, a 10th grader from AMU Aligarh Mini Circle, and the topic of our research is patient-centric pharmacovigilance, development of a mobile application for direct adverse drug reaction reportings.
Uh, Hello everyone, I am Aqsa Athar, an 11th grader studying in Senior Secondary School Girls, Aligarh Muslim University, India. Everyone, medicines are meant to heal, but in some cases they can also produce unintended and harmful effects known as adverse drug reactions. Adverse drug reactions, or also known as ADRs, remain a significant global public health concern and contribute substantially to patient morbidity and healthcare burden. Despite existing pharmacovigilance frameworks, a large number of ADRs remain underreported due to limited awareness, complex reporting procedures, and delayed communication. And to understand this gap locally, we had also conducted a city-wide survey in Aligarh, Uttar Pradesh, India last year, which revealed substantial underreporting of ADRs and low public awareness regarding formal reporting mechanisms. And these findings highlighted the need for a simple, accessible, and patient-friendly digital solution. So, based on this need, we developed the ADR Reporter mobile application to enable direct and timely ADR reporting by patients and healthcare professionals, thereby strengthening pharmacovigilance through a patient-centric approach.
So, the primary objective of this project is to enable simple, timely, and patient-centric reporting of adverse drug reactions through a digital application. The system aims to reduce underreporting by offering an accessible alternative to conventional reporting mechanisms. Another objective is to ensure structured and consistent data collection so that reported information is suitable for pharmacovigilance review. Overall, the project focuses on improving accessibility, usability, and reliability of area reporting at the community level. This project was developed as a containerized web-based application deployed within an Android environment. The development process followed a structured methodology consisting of planning, designing, and implementation or development. During planning, limitations of existing area reporting systems were analyzed and functional requirements were defined. The design phase focused on creating a clean, guided, and user friendly environment to minimize reporting complexity. In the implementation phase, application logic, form navigation, and validation were developed to support structured ADR submissions. The application implements a multi step guided reporting workflow aligned with standard pharmacovigilance practices. Field level validation is used to reduce incomplete or inconsistent submissions. A stepwise form structure is employed to lower cognitive load and improve user compliance. The system maintains structured data capture to ensure consistency across reports. Role based access control separates user reporting from administrative data access, improving data security and accountability. This slide presents key interfaces screen from the ADR Reporter application. The homepage serves as a clear entry point and guides user into the reporting workflow. The severity scale screen provides a standardized method to capture symptom intensity. The credential screen demonstrates restricted administrative access to submitted reports, ensuring controlled data visibility. And now at the results screen, we have a video demonstrating the usage of the ADR Reporter mobile application. As you can see, when the user first opens the mobile application, they are greeted with the home page, where they can see the Start New Report button, which leads them to creating a new report. The first page consists of the demographic information with the age of the patient, gender, weight, and area or locality. In the next slide, we are greeted with the medicine information, where the user inputs the medicine name, dosage, and the course or frequency of the medicine. Here, the user can also add a picture of the medicine packet or the treatment card. And then on the next page, the user enters the starting date of the medication, the stopping date of the medication, and the form of the dosage. On the next page, the user describes why the medicine was taken or the reason behind the taking of the medication. And on the next page, the user tells when the side effect started and what was the side effect. In the next page, the user tells if the side effect is still continuing, if it isn't, the stopping date of the side effect, and if the side effect has happened before. And in the next page, there's the severity scale that we discussed earlier. And here, the user also tells about the known allergies and the known diseases. And now, before submitting, the user can finally see an entire review of their report. Now, when the user hits on submit, they are greeted with the submitted successfully pop-up. And now, if the admins want to see the submissions, they can click on the admin button and enter their credentials to review the submissions directly within the app. As you can see, at the very top is the demonstration submission that we just went through in the video. And this was the ADR Reporter mobile application.
Moving on to the discussion, the developed containerized ADR reporting application shows clear potential in facilitating adverse drug reaction reporting. By providing a simple and user-friendly platform, the application makes it easier for both patients and healthcare professionals to report ADRs without technical or procedural barriers. Preliminary testing indicated good usability with positive feedback, particularly regarding the simplicity and clarity of the reporting process. One of the key strengths of the application is its simple design, which can encourage more users to report adverse drug reactions without any hesitation. However, the current limitations include a limited testing scope and the presence of only basic features, as the application has not yet undergone large scale user based evaluation. Also, future improvements may include the integration of analytical tools, expansion of application features, and linkage with existing healthcare and pharmacovigilance systems to enhance its real world impact. Can yeah. As we reach towards the conclusion, I must say that adverse drug reactions continue to remain significantly underreported, which poses a serious challenge to patient safety and effective pharmacovigilance. Our citywide survey conducted in Aligarh last year clearly highlighted the need for a simple, accessible, and community level mechanism that allows people to report adverse drug reaction without any hesitation. So the ADR Reporter mobile application was developed to address this gap by enabling direct time and patient reporting, thereby strengthening real world data collection and community participation. From a technical perspective, the application demonstrates feasibility through a modular and extensible architecture, providing a structured digital foundation for organized ADR data management. This project represents a scalable and patient driven approach with strong potential for future expansion, system integration, and pilot deployment within formal pharmacovigilance programs. Ultimately, it reflects a meaningful step towards a more inclusive, responsive, and patient centered pharmacovigilance system. Now, I would like to sincerely thank American Society of Science, Engineering, and Technology, also known as ASSET, for providing meaningful opportunities that enable learning beyond the classroom and practical research exposure. I would also like to thank Professor Syed Ziaur Rahman, Chairman, Department of Pharmacology, Aligarh Muslim University, and Dr. Sadia Ayub for their valuable guidance, mentorship, and constant support throughout this project. I would also like to thank SSGE and Ibn Sina Academy of Medieval Medicine and Sciences for their continuous institutional support and encouragement. Thank you so much.
Mohammed Roohan, an excellent presentation. I just have a question. So, do you know what's a percentage of people reporting ADRs in India? I doubt. I know most people don't know about it. Is
Yes,
there
sir.
awareness? So,
Yes,
okay,
sir.
so since you had done this study based on Aligarh, do you know what's the percentage of people who are reporting it?
Yes, sir. So, sir, globally, only about 5% of the people report their ADRs, and specifically in India, it is very bad. Only about 3 to 3.5% of people report their ADRs.
That's a concern. And what about, so is it only for the drug specific or this is also for the vaccines?
So, sir, the vaccines also come under the drugs, and there is also another section which is related to medical devices. So, like the
Yes,
reactions which occur due to medical devices like MRI machines, etc.
yes. But it's an interesting tool. It can help a lot of people to, it can streamline the reporting of ADRs rather than filling the conventional forms and submitting them.
Yes, sir.
One, it is very good approach, and basically if you need help in this, and I'm explaining that what needs to be done here, the app is very good, but the world is changing very fast. This app can be practically written within 1 hour, and in India, uh, the growth of artificial intelligence and machine learning is taking shape very heavily. So my suggestion to you will be that implement it using the AI, and particularly use that Google environment. They have moved and caught up very fast. If you need help, don't hesitate to reach out to me and I will really help you.
Sure, sir. Thank you.
Sure. Good luck to you.
Thank you, sir.
To answer the questions which Abid Sahab was asking, generally in the US, the ADR reporting is around 11%. Thank you.
Sir, can I ask question now?
Sure. Please go ahead.
Sir, first of all, well done, Aksa and Ruhan. Overall, your presentation was exceptionally well organized, and the methodology reflected strong planning. And I have basically two questions which are similar. So first one is that what happens if the same ADR is reported multiple times by different user, and how does your system will handle the duplication?
Yeah, so thank you, Daniel, for the question. So what our system does is in the video, we only showed how the admin can review the submissions within the app. But we also have a backend which was integrated with Superbase. So in the Superbase backend, there are multiple fields consisting of the locality, time, name, and other fields also. So there, if the user, let's say, has an ADR which was rashes or itching, all the itching or rashes related ADRs are sectioned into another group, and from there we can see all the ADRs. So there isn't any problem of duplication of or redundancy. Thank you.
Okay, thank you so much, Rohan. And also, I want to ask that if someone intentionally submitted false ADR data, so how would your system detect or limit its impact? Because if say, for example, that if I want to add a fake data, so how would you detect that?
Yeah, so Daniel, actually, we only made the app which is to shorten the gap between the consumers and the healthcare professionals. At the final stage, a professional reviews all the data, and human effort is the best effort. I always say that. So, after reviewing the data, the healthcare professional can easily tell if it is a genuine submission or just for, overflowing the system.
Okay, Rohan, thank you.
Yes, Assalamualaikum. I have some questions. Yeah.
Yes, please go ahead. Please ask.
So the first of the question is that actually I want to know that who is at the core, means that who is being targeted exactly.
Sorry, I didn't get your question. Could you repeat,
Your
please?
voice is not clear. Can you please repeat it?
Yes, of course. So actually I just want to know that who is the exact audience, means that the targeted audience for whom this has been told, means that mad. You know, one of the condition is that is this for every owner? Oh, this is common that everyone could use it, right? But is there any specific one for whom it was being mad targeting?
Yeah, so I think that you're asking about the target audience for the application. Yeah, so
Exactly.
we kept in mind about the illiterate people or like the local people of India, because like specifically in India the literacy rate is very bad. I'm ashamed to say that as I belong from India, but we kept that population in mind and made sure that the application was very easy to use. And then in future we also hope to add a voice feature where the users can record their voice and report their issues. And also we are thinking about integrating it with AI APIs. So basically it means that we'll be adding some AI stuff into the application. And basically the target audience is the illiterate public, but everyone can use it, even healthcare professionals.
Okay, thanks. This was clear, but after this, my suggestion was going to be this that advice feature and AI, because related people are not likely to be going to enter this data and all this stuff. So this was going to be my next suggestion. But leave that. Now exactly, if possible, would you please elaborate what is exactly going in the backend? I just want to know that.
I'm sorry, I really couldn't catch a question. If you could put it in the chat box, probably.
Okay, I'm repeating just simply that I just want to know that if you could elaborate till what extent, just tell me about what is going on exactly, exactly not till where possible. Tell me about what is going at the back end.
Yeah, so what we do is in the code, we have a different section called main.js. If in a lot of mobile application website, there is a file called main.js. That is the JavaScript file which handles all the logic of the entire application or the entire website, all the button logics, all the graphics, and all the networking information too. So in like a nutshell, we have added like a sort of address in the main.js And when the user submits their report, the main.js goes, okay, here's the report, and I have to put it into the Supabase backend. So it contacts into the Supabase backend, and this thing is basically called an API call. And what this does is tell the Supabase backend that we have a report and we have to store it. So that's basically it in a nutshell.